Okay, I should be live in few moments on both YouTube and Twitter. If not, then let's see. Okay, Twitter is working properly. That's a good indication because till now, yesterday Twitter messed up somewhere. Okay, uh, as I said yesterday, we are not gonna work on ERC 6900. Instead, we are gonna work on building a liquid staking protocol on C because I have looked into it and it's pretty simple, or at least that's how the project starts. We'll see if it's simple or not, but uh, you can start with say documentation. Okay, excellent. This is the most useless thing I have seen, the Brave browser. Document mm, developer developer hub docs. Okay, we found them. Oh, okay, cool. So you can join the Discord also. Their Discord.gg/say SEI. By the time we end the stream, they will have developer office hour started. So cool. That's there. Let's start with like learn about say. There are a lot of videos and articles about what is say, but it's basically they have parallel EVM, not regular EVM like the version of EVM that Ethereum uses is single execution happens on single thread. So that's the limitation. Every late sorry every new CPU or like latest CPU has multiple cores, right? You have 8 core. My machine is I think 8 core 16 threads. So you are, you can optimize the EVM for using all the threads. So that's what Say is trying to do. Say has done. They have used like uh, they have parallelized the execution, and that way the say EVM can use like all the resources of machine and like optimize for usage, optimize machine usage or CPU usage. um, that increases the actual number of transaction that EVM can perform, execute, not perform. Okay, cool. You can go to the docs and see what's happening, like how they are doing it. Uh, I'm not interested in that in particular because that's technically very complex, and personally, I'm not never gonna deal with how say works under the hood. It's not something any regular developer needs to know. Any smart contract developer needs to know because it's complex and you don't have to. You just need to know Solidity. That's the good part of say. You just need to know Solidity and everything will work automatically for you. And you can see their like TPS is 5030 or like theoretical maximum is 12.5k. Right now it's 5k. So these are the features of C. You see, interoperable EVM. CDB is the one, is the thing that like allows say EVM to do execute everything parallelly. Then optimistic parallelization. Um, this feature allows developers to unlock parallel processing for their Ethereum applications with no additional work. So we don't need to understand this. We just need to understand we don't have any additional work if you are working with Solidity. One thing for these EVMs is that you can't use Foundry while developing C, because Foundry uses EVM under the hood like regular EVM, and somewhere along the line it clashes with how C is built. So I'm not sure if there are like tweaks under the hood of that EVM, then Foundry won't work. It doesn't work with ZK Sync, it doesn't work with Nil, it doesn't work with C. So is that's how straightforward it is. Next, our main focus will be this EVM compatibility. EVM compatibility. Let's start with this part. See, it just tells you can use Solidity Viper. Okay, cancel the thing about Foundry. They do have this here, but I don't know if this will work or not. Last time I used it was 6 months ago. Six, no, not six, but like 4 5 months ago. So maybe it works now. Okay, let's try it and see if we fail, we fail. If we pass, like let's see. Okay, I was wrong. I was definitely wrong about just. I was wrong about not supporting Foundry. So let me. Okay, we can go back to our VS Code. Let me create something. Create a was this directory or folder. Say demo. Cd say demo, and we can open that now. Oh no, not this one. I need open folder, say demo. I do trust it. Also, I need a say RPC, say RPC URL. Public nodes, public getaway. Okay, we can just temporarily copy this. It's better to have your own like RPC, um, from something like dedicated RPC from something like Alchemy or Anchor or whatever you like. But for testing, we can just use that. Okay, I'm gonna create Forge init for and copy the config for Soldier from one of our previous project, one of my previous project. Foundry.toml and this part. Okay, soldier init dash clean. Okay, this looks good. We have counter, we don't need to change anything. I just want to deploying EVM contract on say. It says do this, we have this part. Okay, we also need some testnet say tokens, say faucets. Okay, this is not the references, we can't do this. Faucet, yeah. Okay, let me create a new account with Forge. Okay, I'm just trying to go through the documentation, and I remember when you create the account, it shows the private key. So I'm not gonna do that on stream. Cast wallet, cast wallet. Okay, cast wallet new. Cast wallet new. Cast wallet import. Say test. Say live stream. dash dash interactive. Okay, now you guys can come here. You see this part, we have saved this, and we can put this address in the faucet. Find and select unpaired. Say requested. I want to check Explorer. It's testnet says trace. Okay. Hey, hello. Hello to the third person watching on the YouTube. Not sure who you are, but thanks for joining in. We have 5 say to test out things. Back to VS Code. We have forge create dash dash help. Okay, we can use dash dash account flag. Here we have mnemonic flag, right? Instead of that mnemonic, we'll use account flag and deploy the first contract. Forge create dash dash rpc url, and we have to copy the URL from public node dash dash account, say live stream, and then say source slash counter dot sol colon counter. Oh, we just did dry run. Now we can broadcast it. Let's say BROAD broadcast. Will this work? Okay, you are kidding me. There are sufficient funds in the account. Can we get details about that? No. This won't work. It checks the account and that account returns insufficient fund. Sorry, it calls the API to check the balance of the account and it says insufficient fund. Oh, okay, sorry. This RPC URL is for public node, public mainnet node. We don't need the mainnet node. We need the testnet. Say testnet. Yeah, somewhere here we can find out. Just copy from here. Say testnet, copied, back. Okay. Yes, it is deployed. Okay, maybe the issue is not the Forge. Issue is Forge scripts. So Foundry script might not work with whatever we have. This the in our project Foundry script might not work. Okay, uh, I have been proven wrong once before, so keep take my word with grain of salt. But for now, everything works. We have our transaction hash. Let's refresh it. We should be able to see a transaction. Yes, we have a transaction. We don't need to verify it. Let's try to run next part, which was cast call and whatever this is, the function signature, address of the contract, and all those things. Let me go back. I'm just gonna type all that because I know cast call, then get count, un256, rpc url, okay, that didn't work. Can we do increment and then add the account flag, say live stream. If this worked, then we should have another transaction. Okay, no, we don't have that. Okay, I'm just trying to follow the documentation. And cast call, then okay, forge cast, Okay, I guess you guys didn't see what I did. I just did this part where no, sorry. Yeah, I just executed this command and it returned me 0x. So there is error. There was error. Oh no, cast send. Cast send works. Back to our explorer. Let's see. Nothing yet. Oh, yeah, we do have something. We don't have any logs in the details. This is just the function call. Sorry, function selector. This one, it says increment. So that part works. I want to check the Forge documentation. Cast call Foundry docs. Damn. Cast Forge cast. No. Cast call Foundry. Cast call. Okay. Okay. I am trying something. So first call we did was here, right? Execution reverted. This was wrong. That by looking at example that was there in the Foundry documentation, I understood this was wrong. So I changed it to this. Then we got expected one types got 0. Okay, what does that mean? There is no. Oh, sorry. I have deployed the wrong. I have I'm calling the wrong function. Will this work? Yes, it works. I'm the dumb one here. So sorry about that. Let me increment it again. Also, you should have known that I'm the dumb one. Okay, you see, it is getting increased. If we say cast send and then set number UN256, I guess 16. That's how you pass it, right? Yeah, you see this is in hexadecimal, so base 16, and that's how this will work. 0 0 to 0 to 9 and A to F. uh, yeah, 0 to 9 and A to F. You can also convert this to binary, not binary, decimal instead of hexadecimal. Okay, so basic things are, we understood the basic things, how the how to deploy on, say, how to call a say contract, how to how to see all these things on what was that, in the command line and on the explorer. Let's go back to our browser. In the explorer we can, we should be able to see something, some more transactions. Yes, we do have them. We show details, increment, and latest one should be set number. Yeah, set number 16, everything is correct. Oh, someone is watching on Twitter. That's pretty cool. Crypto Doge. I don't know. Not sure if they are watching or not. If they are watching, hi. If not, we'll see. Okay. Next next part is just going in the documentation and looking at the pre-compiles. That's the part which is interesting for us for liquid staking. Interact with endpoints. Yeah, I should have seen this. Yeah, just RPC endpoints, nothing else. Pointer contracts, I don't know what they are, but I do know what are precompiles. So say is built on top of Cosm Wasm, sorry, not Cosm Wasm, Cosmos HDK, and this is one of the modules. Like EVM is one of the modules, and other modules are there. So the staking actually is like the module in Cosmos HDK, and if you want to interact with that staking module, you have to use these precompiles. So that's why they are here. One of the precompile, we will use two precompiles, which is distribution and staking. So staking is straightforward. Like if you want to stake your, what was, sorry, if you want to stake your say from EVM, from a smart contract, you will use staking precompile. It has delegate, redelegate, undelegate, and one query, which is delegation. Yes. Last year, it says, really? Okay, staking.sol. I guess it was old one. 1D. This is not correct. I'm pretty sure of that. Maybe I'm just looking at the wrong thing. Sorry, say chain EVM precompile staking. Say chain precompiles staking staking.sol. Yeah, you see delegation queries there, all these things, and now distribution. So all the staking, like why we do staking is for like proof of stake, right? You want to contribute your tokens to network security, and network will reimburse you with some reward. So distribution precompile does that. Whenever there is a reward, you can withdraw that to your account. You can query the reward. This is here, or you can just withdraw the reward, and it will come to your account. You can withdraw from single validator. Set withdraw addresses. It says sets the EVM address. So on, say there are two types of address, which is say native say address and EVM address. So this function just like sets connects those two, or does something like that, where you will set up the address, and when you call withdraw, your rewards will be given to this, or withdraw multiple delegation rewards. These two things are there. Okay, next we can create a diagram, like how that should work. We have one. Let's say like what are the steps user wants to get LST, so which is liquid staked tokens. First step, user calls a function. Okay, sorry about that. I'm back. User calls the function on contract to deposit native say tokens. Contract returns the user ERC20 token. Then the delegation bot on set intervals delegates the token delegates tokens to different validators. Next part, also on set intervals, bot calls a function on contract that withdraws the reward from validators, and then calls delegation function to do the same thing. When a user wants to call sorry when a user wants to undelegate or no redeem the LSTs, user calls a function on contract withdraw, and based on the exchange rate calculated in the contract, it returns native say token to the user after the undelegation period. Okay, so for contract, for delegating, undelegating, and withdrawing the reward, no, for delegating and undelegating, contract calls a precompile called delegation. For withdrawing the reward, it calls a precompile called distribution. Okay, let's put that in the text to diagram prompt, and it should generate something for us. Let's see what it generates. Smart contract delegation bot validators precompile. Oh, this is pretty good. Yeah, this is the diagram. So let's zoom in and see. We have user, smart contract, delegation bot validators, and 2 precompiles, which is basically under precompiles also works. Calls deposit function with native say tokens, returns ERC20 tokens. That works. That's correct. On set intervals, bot will call delegate function. It will delegate to validators. So we are calling delegation precompile, and which delegates the token. We call withdraw rewards withdraw rewards is called and reward is returned. Bot calls the delegate function which redelegates the reward, and that again goes to validator. When user calls withdraw function, we call smart contract calls undelegate, and native say is native return native say tokens after undelegation period based on exchange rate. Okay, this is not exactly correct. So return native say tokens based on the exchange rate after undelegation period is over. Okay, this is some this is correct. We have to make minor change. Okay, these undelegation requests are stored and bot calls undelegate on set interval. Okay, so we won't allow users to directly call the precompile, or users to call function that directly calls precompile, because it won't fit in our delegation strategy. So that's the part here. So we'll have one function for delegation, undelegation. No, one function for withdrawal and another function for undelegation. So withdraw function will be called by, okay, in this we will have withdraw function that creates the request, and undelegation function on contract which bot calls on set interval. Okay, what happened? I guess I'm going over the character limit. Yes, I was. This is our first version. This will be our second. So is this correct? First part is correct. Second loop, delegate tokens calls delegate precompile. That's correct. Withdraw reward call delegate function call delegation precompile. This is also correct. We can remove this. Here we need to make change. return native say tokens after undelegation periods. Okay, this is correct. Yeah, this is exactly, this is what we want. So let's save that. Export image, save png. Okay, I'm also gonna save the prompt for now. Okay, what else is remaining? I think actually starting on the idea, that's the only part which is remaining. We we understood the basic flow, right? We'll have a, this is our staking, liquid staking contract. Our user, our delegation bot, and these are the precompiles. Interaction between precompiles and validators, it doesn't matter for us because we are just like doing the, we are executing function on the precompile, and whatever precompile does under the hood, it's, we won't care about it. First user comes, they want to deposit native say, and will return ERC20 token. So that exchange will happen. Then all in a particular interval. So if we have 1 hour, in that 1 hour, whatever deposits we get, will go and uh, will go and delegate those to a validator. So, not we, our delegation bot will call delegate function, and that delegate function will call delegation precompile, and delegation will happen, actual delegation. Same thing will happen with rewards. So all the all the delegations we have will generate some reward, right? That reward we first need to withdraw. There is no auto redelegation in Cosmos, so we have to withdraw those reward and then again call delegation function. Not again, we can before this only. Can we just move it up here? And this, oh no, control Z. We don't need this part. We can just, yeah, we can just in the loop only, first we'll withdraw the reward and then call delegate token. Our bot will do that instead of whatever we had previously. All this thing we can move up. Okay, this is just ridiculous. No, I'm doing something wrong. Okay. Anyways, you understood this part. Then in the redemption, we have one issue which is undelegation period. In say, I think it is 21 days. So for that those 21 days, we can't remove. We won't get our tokens back, and that's where this part comes in. So whenever someone calls redemption redeem function, uh, we'll create a request for that redemption. Then we'll call this. Uh, all those requests will be compiled, or like yeah, all that amount will be added, and our bot will call. Okay, here one step is missing. Our bot will call contract, and contract will call delegate precompile. In those 21 days, um, we won't get any reward on those tokens. So we need to note down the what was note down the exchange period, exchange rate that is there. Um, LST LST to native say that exchange is there, right? So we also note down, need to store that somewhere with the request. And after 21 days, user can come to our web app or whatever it is and remove their tokens to their wallet. So that's the general flow. Let's see. Yeah, that's the general flow. Tomorrow we'll actually start writing the contract and basic structure of it. I have written one already. It was 6 months ago. So it's EcoSafe, EcoFinance. Yeah, you can go to MVP branch and check this eco staking. All these things are there. Yes, you can check that. But anyway, tomorrow we'll actually start writing it, and I'll explain each and every part of it, and we'll try to do this like very correctly so we can add this on our portfolio if you want to. I don't want to. I'm just doing this for fun, but this will be very good portfolio project for anyone who wants to do this. Cool. I hope you like the I hope you like the today's stream. And yeah, you already know tomorrow's topic, so hopefully you will be here tomorrow. Cool, then have a nice day, and bye bye.